Welcome to our presentation on transportation of dangerous goods. This group presentation will be conducted by Rob, Mike, Karen, Usha, and Miriam. The presentation will cover general information regarding dangerous goods and TDG regulations, hazards and operating experience, Class 7 shipment regulations, packaging, testing, and shipment of Cobalt-60. In this section, we will be covering general information regarding dangerous goods, TDG, its classes, and importance of compliance with the TDG regulations. Dangerous goods are any product or substance that poses harm to living organisms or the environment. According to the Canadian Centre for Occupational Health and Safety, a product is considered to be a dangerous good if it's listed in Schedule 1 or 3 or outlined in the Part 2 of the TDG regulations. These goods can be in any physical forms, whether that's solids, liquids, or gases. According to the Canadian Centre for Occupational Health and Safety, the purpose of the TDG Act and regulations is to promote public safety and establish safety requirements. The TDG regulations are essentially a set of rules for safety and shipping requirements and encompass an extensive list of dangerous goods. These regulations help to clearly identify, illustrate, and communicate the level of risk associated with each type of dangerous good. The Canadian Centre for Occupational Health and Safety has divided dangerous goods into 9 classes. To the right of the screen, the classes of dangerous goods can be seen along with respective application and description. Please note the order of the classes 1 to 9, do not increase based on the degree of danger or risk. Rather, they're based on the type of hazard each dangerous good presents. To the left of the screen, the dangerous goods labels and place cards are illustrated with the appropriate classes, which help for easy identification of the hazards. These place cards and labels must be clearly visible and placed on all containers and packaging before handling of the dangerous goods. So who must comply with the transportation of dangerous goods regulations? Everyone handling dangerous goods in the course of transportation or following transportation must comply with the federal TDG regulations. Handling refers to loading, unloading, shipping, transporting, packing or unpacking, receiving, or storing dangerous goods. The Canadian Centre for Occupational Health and Safety recognizes 3 categories or groups of industries that must comply with the TDG regulations. These include suppliers, which are individuals that ship dangerous goods, transporters, companies that transport dangerous goods, and buyers, that are individuals that receive dangerous goods from the suppliers. The Canadian Centre for Occupational Health and Safety outlines the key elements including training, classification, preparation of documents, safety markings, selection of appropriate packaging, ERAP, and reporting incidents. However, the most important element of TDG is training, which must commence before employees can handle any dangerous good. Handling dangerous goods in a secure manner is essential to maintaining safety. Insufficient training or lack of following the TDG regulations can result in accidents which can put everyone at risk, including people, property, and the environment. So all employees in a nuclear power plant that handle dangerous goods need thorough training on TDG before commencing work. Developing a safe mindset is a significant safety component. One must recognize that safety is a responsibility of every individual to keep themselves, the public, and the environment safe when handling dangerous goods. Upon completion of training, employees receive TDG certification in order to work with dangerous goods. In doing so, individuals acknowledge that they have the necessary knowledge and skills to work with dangerous goods and are a responsible, safe employee. Class 7 of the dangerous goods are characterized by radioactive materials. These radioactive nuclear substances emit radiation which even has the potential to damage body tissues. Handling these dangerous goods therefore requires meticulous procedures, training, and handling equipment. Some examples of Class 7 materials include uranium metal, isotopes, radioactive ores, among many others. There are 3 categories of Class 7 dangerous goods ranging from radioactive category 1 to 3, which indicates the surface level radiation for the dangerous goods content and activity.
Let's talk about the hazards associated with radiation, specifically radioactive material, and the operating experience in shipping that material. So, what is radiation? Radiation is essentially energy that's released by atoms in the form of electromagnetic waves or particles, actually present everywhere. There are 2 types of radiation, essentially non-ionizing and ionizing. Ionizing radiation is low-level radiation that we get from things like radio, the microwave that we use every day, or sunlight. While ionizing radiation is high-level radiation that comes from like nuclear power plants or X-rays. 3 different types of radiation in terms of ionizing radiation, alpha, beta being the particles that we talked about, and gamma being the wave. So dry storage containers are essentially used to transport spent radioactive waste from usually from sites to the nuclear waste facilities. So as you can see, those containers are quite tall and weigh up to 70 tons and are, as you can see from the picture on the man, in comparison to that container. Here's an example of a truck that's used to transport that dry storage container. And so this presentation will go more further details into how radioactive material is transferred and the regulations associated with it. As you can see, it looks like a normal transport truck. Let's talk about transport trucks in general. Transport trucks are used for transporting many goods. Accidents related to transport trucks can be fatal. As you can see from the table, transportation trucks account for 20% of the deaths on road. In Ontario alone, we had about 15,000 collisions related to transport trucks. These are some of the pictures that are associated with accidents revolving transportation trucks. So now just imagine if any of these trucks contain the radioactive material. While Canada has a good, exceptional actually record of with regards to transportation of radioactive material, there have been accidents around the world, notably in the States where you can see 18 since 1949. Notable accident in the US was in 1971, so December of 1971, where we had a truck carrying spent fuel cask. Cask is similar to a dry storage container I was shown earlier. So in this case, the container, actually the vehicle veered off the road to avoid a collision. And the driver was killed, cask was damaged, however there was no radioactive material released to the public. As you can see some of the pictures of the cask and man monitoring the radiation levels on the outside of the cask. There have also been some accidents involving transportation trucks in terms of loading due to weight of the cask, bolting of the cask loose and missing. And in some of these cases, and actually all of these cases, there were no radioactive material released to the accidents. It does highlight the need to have regulations and safety protocols in place. In addition to the transportation truck, there have been radioactive resources that have been lost or stolen. So in one case here, you had an employee that lost visual contact with the device and the source was stolen. It highlights the need to have proper oversight on such devices. Second example below, you can see the workers were exposed to radiation, resulting in radiation burns. A source was misplaced during operational activities. So these incidents highlight the need for strong Class 7 shipping regulations, which is our topic for our next discussion.
Hi everyone, this is Rob Martin. In this section, we will quickly cover the regulatory requirements for shipping Class 7 material. There are two major regulations which cover radioactive material shipments. The first is transportation of dangerous goods, which was discussed by Miriam at the start of this presentation. The second is called Packaging and Transportation of Nuclear Substances, which is a document produced and enforced by the Canadian Nuclear Safety Commission, or the CNSC, which focuses on the categorization, classification, and packaging of radioactive material. The document is heavily based on IAEA regulations or International Atomic Energy regulations on the safe transport of radioactive material. So what are your duties as a Class 7 radioactive shipper? You'll be responsible for mainly classifying the waste. This means identifying the form of the material, either solid or liquid, and determining its approximate activity level. After that, you are responsible for selecting the collected package based on the activity level and associated IAEA regulations. You must ensure that this package is not damaged and has been tested and surveyed to meet the appropriate regulatory requirements, which will be discussed later in this presentation. You are also responsible for receiving radioactive packages. This includes conducting a receipt inspection, preparing and maintaining document records, and initiating an emergency procedure if an accident does occur. Documentation. This is probably the most important slide in terms of maintaining compliance with the Canadian Nuclear Safety Commission, since the shipping form and other forms of documentation is one of the first things the CNSC inspector will ask you during an inspection. Your shipping document must show the contents of your Class 7 package, including the radionuclide and approximate activity level, the name and the address of the person or organization receiving the package, the origin of the package, such as the address and the original owner, and a 24-hour emergency contact in case the package is lost or damaged during transit. The shipping document and your TGD training certificate must be readily accessible when transporting your Class 7 package. Emergencies which occur when transporting a Class 7 package are called dangerous occurrences. These can include anything from a traffic accident to a leaking or lost radioactive package. The Class 7 shipping organization is required to have an emergency procedure and radiation protection expert available in order to limit the spread of contamination if an accident occurs, erect safety barriers if required, record incident information, and notify the CNSC within a 21-day reporting period.
Class 7 shipment packages. In this section, we will be covering transportation of dangerous goods, Class 7, characterization, package selection and types, and an overview of testing and associated requirements. Before selecting a package, first the contents must be identified and characterized. For many reasons, including public safety and financial, a risk-graded approach is applied. It depends on three key factors: determining the physical form of the radioactive contents as a solid, liquid, or gas, the specific activity of the contents, and the radiation dose rates of the package once the contents are put away. Some examples from nuclear power plants can include spent ion exchange resin, contaminated equipment, or liquid waste. There are 5 main types of packages. Type C and B have generally the same type of contents, which are high activity, but the difference in Type C packages is that they can be transported by air. Type A is a lower risk due to lower activity contents, and an accident during transportation poses much less risk and can generally be tolerated. Industrial packaging or accepted packages are very low risk. Therefore, a risk-based graded approach is used. Expected packages are used when the contents have very low levels of activity. These include items such as large quantities of smoke detectors, which contain small amounts of radioactive material. But how low is considered acceptable? The IAEA regulations use the formula shown on the slide to determine the threshold. Low specific activity contents go into industrial packages with 3 major types. LSA-1 contains low activity solids, such as naturally occurring uranium or thorium ores. LSA-2 is low activity liquids. These are generally harder to contain than solids, therefore a more robust package is required. LSA-3 is an elevated activity solids. So this is solids that have a slightly higher specific activity than LSA-1. Thus, a more robust package is required. These limits are documented in the IAEA regulations. Surface contaminated objects are defined as materials that have fixed contamination on the surface of the object. These objects can also go into industrial packages similar to the low specific activity items which were just previously discussed on the previous slide. There are 2 types of surface contaminated objects. SCO1 having a lower threshold for contamination, meaning the package design requirements can be less robust than the SCO2. If both of these SCO thresholds are exceeded, the package cannot be classified as such and must be reclassified as Type A or B as appropriate. Type A or Type B are much higher risk when transported due to the higher specific activities, which increase the maximum reasonable potential for harm. Using the IAEA regulations and formulas which were previously used, a similar approach can be used to classify the contents and the risk into Type A or Type B. The fundamental difference between the two is the specific activity, and thus Type B packages are designed to withstand higher activities and are much more robust. Every type of package is designed to meet a certain criteria of specific regulatory requirements, which are aimed to protect the public and the environment and set a high standard, such that during all normal transportation conditions, and in some cases accident conditions, the risk to the public and the environment is minimal and acceptable. Using a risk-based approach, Class A packages are tested under normal operating conditions, i.e. do not include extreme accident conditions. This is because Class A packages have much lower activities, therefore the risk is much more tolerable than a Class B package. Type A package testing involves 4 tests that must be completed prior to using the package. These tests must be deemed a pass, which ensures the package integrity is not compromised when the package is subjected to normal anticipated events. The water spray test simulates rainfall at a rate of about 2 inches per hour, which the package could be subjected to in its travels. The free drop test involves dropping the package from a defined height based on the package total weight. The maximum height that could be expected is approximately 1.2 meters. The compression test ensures the package cannot be damaged by a crushing force of 5 times the package weight, or nearly 2 psi of force being applied to all sides. The penetration test involves dropping a 6 kilogram rod at the package. These tests mimic day-to-day reasonable incidents that the package must endure and maintain its integrity. Type B packages must undergo and pass all of the Type A test, i.e. the normal operating condition. However, because Type B package contents are a much higher activity, these Type B packages also must be able to endure an accident condition. Therefore, a Type B package must successfully undergo all of the Type A tests with the following additions. The free drop test has a new height of 9 meters. The fire exposure test assumes that the package must be able to withstand a fire of about 800 degrees Celsius for about 1 hour. And as well, since the package could be shipped by rail, must also survive a rail car explosion. A CAS test assumes a transport vehicle accident at high speed. The train accident test involves crashing a diesel locomotive traveling at high speeds into the package. The water immersion test assumes that the package has become dislodged or has fallen off of a boat, and the package must be able to withstand 15 meters of head for a time period of roughly 12 hours. The Type B test videos that demonstrate these tests being performed can be found in the following YouTube links. I highly encourage that everybody take the time to review these tests. In this training video, we will cover how to perform certification testing on a Type A package. Now, this package is assumed to have been designed already to the required IAEA and CNSC regulations. This training video is going to focus purely on certification testing of the package. If you recall why testing is important from our previous slide, a Type A package must undergo the required testing to normal transportation conditions. It does not need to cover accident conditions because the contents that go into Type A packages are a lower risk due to the lower activity of the contents that go in. The success criteria of these tests is that the package must remain intact and the contents do not leave the protection of the container. The normal operating condition tests are shown here: the water spray test, the free drop test, the compression test, and the penetration test. The following slides and as well videos demonstrate how to perform each test. In order to perform the free drop test, as you will see in the next video, the drop distance must first be calculated. This is calculated by using the IAEA regulations and the table, which shows that for our maximum weight of approximately 10 to 20 pounds, our paint can must be dropped from a height of 1.2 meters. This height is calculated from the bottom of the package. The compression test. Using the criteria of 5 times the maximum package weight or 2 psi times the vertically projected area, we get approximately 50 pounds worth of compression test. This is done by using weights, and the package is put under the compressive force for roughly 24 hours. In order to perform the penetration test, a 3.2 centimeter bar, which weighs at least 6 kilograms, must be dropped from a height of at least 1 meter vertically onto various areas of the static package. Because this type A package is small, one test must be performed. Lastly, the water spray test must expose our package to simulated rainfall at a rate of approximately 2 inches per hour. No water can penetrate the package, nor can the contents come out. With completion of the 4 tests and the smashing success of our results, this concludes the testing portion of a Type A package. These test results are documented along with a detailed design and analysis of the package. The CNSC approval is not required as it is only required for Type B or C packages, but Type A package testing must still comply with the codes and standards.
So we are nearly halfway through the training session. I bet you are wondering how much of this information you have to actually know in order to be a good Class 7 shipper. To answer your question, we have attached a short film of Class 7 shipper USHA's very first CNSC inspection. Watch closely and we will summarize what can be improved on the end. Hi, how's it going?
Good, how are you?
Not too bad. My name is Rob Martin. I'm the Inspector with the Canadian Nuclear Safety Commission. I can see from the safety marking on your car that I think you're transporting radioactive material.
That's correct. I'm transporting cobalt-60 from Pickering Nuclear Generating Station to the Nordion facility in Canada, Ontario.
That's great. Are you ready for a CNSC inspection?
Yep.
Excellent. Can I start with your TGG card, please?
Sure.
Can you show me your shipping form next, please?
Yep.
Thank you. So what type of package are you transporting today?
It's an accepted package.
What sort of emergency procedures do you have in the event of an accident?
Well, in the event that my car is stolen, I would just call the police.
Is there a 24-hour emergency contact on the package?
So my number's on the package, but I'm only available 9 to 5 on weekdays and not available on weekends.
So what went wrong with that inspection? The first thing was that the Class 7 shipping markings, which was the trefoil, were not in color and were not to IAEA specifications. The second item was that USHA's TGG card was out of date and expired. Her shipping form should have been in the glove box, accessible from the driver's seat. Her cobalt-60 package was incorrectly classified, should have been a Type A package, and instead was shipped as an accepted package. Detailed emergency response procedures were not known or readily available to serve as a reference. The 24-hour emergency contact number was not available and was not clearly marked on the package. In summary, 99% of your CNSC inspections will likely be nearly identical. Ensuring you are prepared with the current TGG card, correct shipping form, package classification, and emergency procedures will ensure you are ready to ace them when they happen.
We will now go through a real-life example of transporting a radioactive substance from a nuclear power plant. Cobalt-60 is a prime example of a Type B package. Cobalt-60 is an isotope that emits gamma rays and is produced via irradiation in nuclear reactors. Approximately half the world's supply of cobalt-60 comes from Ontario. We will now watch a video on where cobalt-60 is actually used in the world. Note that this video is sponsored by Ontario Power Generation.
think about nuclear power, they think about electricity and ensuring their lights are kept on. The previous video showed how cobalt-60 is used in the food industry, but for the healthcare industry, nuclear power impacts them in two ways. Firstly, it keeps the lights on in the hospitals and supplies power to life-saving equipment. And secondly, the use of cobalt-60 as a medical isotope is used for sterilization of medical equipment in hospitals worldwide. Medical-grade cobalt-60 is also used worldwide in radiation-based cancer treatments. We'll now discuss the process in producing cobalt-60. Cobalt-59 is first mined and transported to the manufacturing facility where it becomes cobalt-59 pellets and slugs. The plant then assembles the source elements and the adjuster rods, and then delivers them to the nuclear generating stations. The cobalt-59 adjuster rods are then installed in the reactor during planned outages, and over time, the cobalt-59 is activated to become cobalt-60. The cobalt-60 rods are then removed from the reactor and stored in the AIFB. Over the fuel bay, specialized fuel handlers extract the individual irradiated rods and place them in a shielded flask to be shipped off by Class 7 shippers to the processing facility. At the facility, the cobalt-60 is processed into sources. Once this is complete, the sources are then shipped off to the customer. Since a significant portion of the world relies on the production of cobalt-60, it's imperative to understand the process and ensure environmental health and safety. We must ensure the safety of all employees, customers, and the general public when shipping radioactive material. As nuclear professionals, we must enrich the safety and well-being of our employees to ensure safety is everyone's #1 priority, and to continually look to improve overall environmental health and safety.
We will now conclude our presentation with a short advertisement reminding you that you are our first and most effective barrier against the hazards presented by Class 7 radioactive material shipments. Always remember that working safely is your primary objective.